We're going to talk about some more similar polygons, and remember that those, when they're similar, that means that they have a common ratio for those side lengths, and that's what we're going to be calculating today, calculating what that common ratio is, but then also maybe finding some of the missing side lengths. So we're going to look at this first example, and we're going to use these two similar figures to answer these questions. So remember, this is our sign that two things are similar. So they're telling us that these two polygons are similar to each other by that denoting that sign in between them. So we're going to see how we're going to work and find that common ratio between these two quadrilaterals, and they're named A, B, C, D. So A, B, C, and D, and it's similar to E, F, G, and H. And so remember that order does matter. So we're going to show that the ratio of the perimeters is the same as that common ratio. And let's just say, you know, the ratio from, you know, line A to B should be is similar to line EF, and that ratio should be consistent throughout, and that's what we're going to be looking for today. So our next line is BC, and it should be similar to FG on the other one. Then just keep going around. We should have that same ratio between CD and GH. And then the last one would be DA to HE. And so now, let's go put in actual numbers, and we're going to show that these ratios are all the same. So AB, that length between the two is 5, the length of that line. Then the line EF is 2.5. BC is 6, and FG is 3. CD is 8, and line GH is 4. DA is 10, and then HE is 5. Okay, so if we go on our calculators or in our heads, 5 divided by 2.5, we're going to see that that ratio is 2. 6 divided by 3 is 2. 8 divided by 4 is 2. And 10 divided by 5 is 2. So these are all the same. So that means we have a common ratio here. They're all 2. And so that would be the common ratio of our equilaterals EFGH to the quadrilateral ABCD in the example above. Okay, so you see how that works. So now the questions might be determine if they are similar. And so if we're going to determine it, then we're going to look and see, are those proportions the same? Are those ratios between the two the same? So we're going to have to look at figures and maybe make sure that we understand which are the common sides that they have. So let's just draw here or color here that we have this side should be similar to this side, right? And if we, again, when you're setting up these ratios, if you want to say, I'm going to use the big one over the small one, doesn't matter, okay? So we're going to say that is 9 to 6. And let's change colors, and let's see, hopefully our proportions will be the same here. Here it's the next line, 3, and it corresponds to this one. So is 3, 2. Still using the big to the small. Okay, let's go to the last line. This should be this one. And we're going to compare it to this line. So 18 to 12. So we saw in our example above then that these proportions should be the same if these figures are similar. If they are not all the same, then we know that our figure is not similar. Okay, so let's see. 9 divided by 6 is 1.5. Is that equal to 3 divided by 2? 1.5. Is that equal to 18 divided by 12? 1.5. So we have a common ratio of 1.5. So therefore, the two figures are similar. Now all it takes is for one of these to not be the same, then our figures would not be similar. Okay. So let's look at another example. We're going to use this one to answer the questions below. So the quadrilateral EFGH is similar to the quadrilateral over here. So we're going to have to make sure that we use the same order so that they would be similar. So E is the first one that we're given, and it would have to correspond with which letter on the other quadrilateral. Well, we're also told that this angle has the one mark, so we're looking for the angle on the other one that has the other mark, and that is angle A. Okay, so then we're going to 2, so that's B. Going to the 3 marks, the one that corresponds with G then would be C. The one that corresponds with H is D. So we would say it's got to be quadrilateral EFGH is similar to quadrilateral ABCD. And those letters matter. So if you put those letters out of order, that makes it incorrect because they have to have their corresponding sides. All right, so what is the common ratio? Okay, well, we're told that they're similar, so we can just even use one of them, and we're only given 2 here, so we've got to say what's the ratio between 10 and 2.5. And that is 4. Okay, so we don't have to check all of them because we're already told that they're similar. Up here, we were on the example 4, we were told to determine if they were similar, so we had to check all of them. So their common ratio then is 4. Okay, so then find the following. If we're finding x, then we want to set up that ratio. So we say 10 is to 2.5 as, because that's the one we know, so what corresponds with the side x on the other triangle, or the other quadrilateral, sorry, 12. So that should be 12 over x. And again, we're going big one over that smaller one. And there you would cross multiply. So that's 10x is equal to 12 times 2.5 gives us 30. So 30 divided by 10 x is 3. That ratio, so then now we could even put 3 in there if we wanted to and say 3 because we're going to go check all these. So now we're looking for y. Okay, so now we know y is on our big triangle, so y is going to be on the top. 3 is going to be on the bottom, and we can just continue to cross multiply. You can either go back to the very first one, or you can use the one that you just came up with and just continue to cross multiply. So 12 times 3 is 36, and then 3 times y is 3y. Divide both sides by 3, so y would be 12. And then we're looking for z now. It corresponds with the 5 on the other side. So that should also be 5 is the big one. Z is the small one, so that's what you're really going to have to be careful to watch those and make sure that you're setting them up correctly. So now our Y is 12, and we can cross multiply there. So 5 times 3 is 15, and 12 times Z is 12Z. And divide both sides by 12. So that's 1.25. for Z. All right, so what is the ratio of their perimeters? Well, we already found the ratio of the perimeters. So if we add up all the sides for the perimeters, let's see, what is the perimeter of this? So let's go fill in. Y here was 12. X here is 3. And Z is 1.25. So let's find the perimeter of the EFGH. Okay, so we have, remember, perimeters outside edge, so that's 12 plus 10 plus the other 12 plus 5. So that perimeter adds up to 39. The perimeter of the other quadrilateral, ABCD, let's add up all those sides. We've got 3, 2.5, 3, and then 1.25. Add all those up. Remember, it's important to line up those decimals when you're adding with decimals. And I got 9.75. Okay, so what's the ratio of EFGH? 39 to 9 7/75. How do B and D compare? Okay, so if their common ratio is 4, if I'm to say, well, what's 39 divided by 9.75, we should get 4. And we do. So they are the same because it's the same ratio. All right, let's look at another example. Use the similar figures below to answer the questions. All right, so this should be getting a little bit easier. So we're going to find the common ratio of the polygon RSTUV to the polygon ABCDE, and then we're going to find the values of those that are missing. Okay, so we've got to start going in order. Which ones do we have? If we have RSTUV, I've got 18 on one line, and that should be comparable to the 4. So what is that ratio? 18 divided by 4 is 4.5. So that should be our common ratio. All right, then we can just use cross multiplication again to find our x and y's. The x value here corresponds to this one. So x is to 3 as the one that we know, 18 is to 4. And then I did the big one on top with the small one on bottom. We're going to cross multiply again. So 4x is equal to 18 times 3, which is 54. Divide both sides by 4. So x is 13.5. So then we're going to find a y, and it corresponds to the 5. So we're going to say, again, the big one, y plus 2 over 5 is equal to the one that we know, 18 over 4. Cross multiply again. Remember, you have to distribute that 4 to the y plus 2, and then 18 times 5 is 90. So that gives us 4y plus 8 is equal to 90. We'll subtract 8 from both sides. And that gives us 4y is equal to 82. Divide both sides by 4. So 82 divided by 4 is 20.5. So you're going to use proportions a lot throughout several of your different math classes. Okay, so we can complete the following. I think we should be able to do this. So angle E, if ABCD is with EFGH, is similar to EFGH, angle E has to be congruent to the measure of angle, oh, I guess it actually wants us to find them. A, which is 60 degrees. Okay. Angle G, remember that box tells us that it's 90, so then that should be the same as angle C, which is also 90 degrees. So angle B corresponds to angle F, which is 100 degrees. So then H, well, how are we going to find out what H is if we don't know what D is? Well, do you remember that all quadrilaterals should equal 360 degrees? So we could see what's missing. So let's say 360 minus the 100 of the angle that we know, minus the 90 of the angle that we know, minus the 60 of the angle that we know. So we'll take all those, subtract it from 360, and that should give us 110. Okay, so now it's telling us to find all of the remaining side lengths. So EH, we don't know, but we know its corresponding side is 5. So we're just going to set up proportions for all of these. So let's go small this time to big. Okay, so we're saying 5 is to something we don't know, as, which are the ones that we do know. We do know 6 and 18. Okay, cross multiply. 6x is equal to 18 times 5, which is 90. Divide by 6. So x is 15. Okay. Then we're going to go find, let's see, BC. So now we're looking for this one. I'll say that one's y. So its corresponding one is 9 on this side. So y is to 9. The one that we know, 6 is to 18. So 18y is equal to 9 times 6 is 54. So 54 divided by the 18. So y would have to be 3. And then the last one, it's asking for AB. We don't know that one, so let's say that's going to be Z over 21. It's corresponding on the other, is equal to the 6 over 18. So 18Z is equal to 21 times 6, which is 126. Dividing by 18 gives us 7. Okay, I think you can do the rest of those. That's not too bad, so we'll end there.